Chapter 10, we will learn the typical techniques used in speech enhancement. The speech enhancement techniques mainly focus on removal of noise or other interferences from speech signal. Section 1 will have an overview of speech enhancement and introduces the various types of noise. The presence of a background noise is problematic for humans and computers alike, and the problem of dealing with it, called speech enhancement or noise reduction, is an important and long-standing problem in signal processing. The search for new and better methods continues today. The purpose of speech enhancement is to extract as pure original speech as possible from the distorted speech signal. Speech enhancement has two main goals. The first one is to improve voice quality. Eliminate the background noise, make the listener willing to accept it, and not feel tired. For example, in voice communication, like a mobile phone call or VoIP, users would like to hear clear voice and feel comfortable with good speech quality. The second one is to improve voice intelligibility, making listener easily understand. For example, hearing aids and cochlear implants need to design algorithms that can improve speech intelligibility without sacrificing quality. The wider concept of distortion to the speech signal contains background noise, reverberation, and some other interference. In most of the applications, speech enhancement aims to enhance the corrupted signal by reducing noise. How to measure to listeners' performance on degraded speech? How does speech enhancement improve the performance? One way quantifying speech perception performance in noise is to measure speech reception threshold, SRT. That is the speech-to-noise ratio needed for 50% intelligibility. Experimental results found that each 1 dB gain in SNR corresponds to about a 10% increase in intelligibility dependent upon materials. Speech enhancement algorithms are important components in many systems where speech plays a part, including telephoning, hearing aids, voice over IP, and automatic speech recognizers. Speech enhancement is generally concerned with the problem of enhancing the quality of speech signals. This can, of course, mean many things, but it is often associated with the specific problem of reducing the impact of additive noise. The originally clean speech will be degraded with background noise, which leads to noisy speech with different SNR. Lower SNR means larger noise energy. There are some speech samples to show the performance of different signals with different SNR.
Bin Blue F2 now. Bin Blue F2. Bin Blue F2 now. Bin Blue F2 now. BIM Blue F2 now.
For voice communication system, the original speech is compressed and sent to the transmission channel. The channel impairment leads to transmission noise, which needs to be eliminated from the degraded speech at the receiver. In general communication, additive randomness is regarded as the background noise of the system, and multiplicative randomness is regarded as the time varying, such as fading or Doppler or nonlinearity of the system. There are many types of noise, mainly divided into additive noise and non-additive noise. To ensure our normal communication and health, we need a speech enhancement technology. In speech communication, the additive noise is generally regarded as the background noise. Additive noise comes in many forms. For example, ignition and discharge can cause impulse noise. Its time domain waveform is a narrow pulse similar to the impulse function. Method of eliminating impulse noise is to average the amplitude of the noisy speech signal and use the average as the threshold. If the threshold is exceeded, it is judged as noise and filtered in time domain. When the impulse pulse is not too dense, the impulse point can also be avoided or smoothed by interpolation. The mid-air filter is the most popular choice for removing the impulse noise when restructuring the speech. Periodic noise such as engine interference and electric supply, city power, has some correlated component. It appears as a discrete narrow spectrum in the frequency domain, which can usually be eliminated by the notch filter. The filter should be designed to remove the periodic noise while preserving speech intelligibility. Wideband noise is a kind of additive interference that is difficult to eliminate. Because it has the same frequency band as speech, and it will affect the quality of speech after eliminating the noise. For example, when speaking, it is accompanied by noise caused by breathing. Wideband noise includes noise generated by random noise sources or condensation noise, and so on. In applications, wideband noise is approximated to Gaussian noise or white noise. The noise spectrum is spread over the spectrum of the speech signal, making it difficult to eliminate. Generally, we need to use nonlinear processing methods, such as spectral reduction, Wiener filtering, maximum likelihood estimation, and so on. Another kind of additive noise is speech interference. It is caused by interference between a voice signal and an interference voice signal to be transmitted simultaneously in one channel. For example, crosstalk in communication. The way to distinguish them is to use the difference of pitch. The comb filter can be used to extract the pitch and harmonics, and then the useful signals can be recovered. Here are some examples of additive noise. Impulse noise, like explosion, impact and discharge. Periodic noise, for example, alternating current. Smooth noise, for example, white noise. Non-stationary noise, such as color noise. Additive noise means the relationship of speech signal and noise is addition. Non-additive noise includes multiplicative or convolutional operation between signal and noise. Multiplicative noise, for example, circuit noise of the transmission system, is seen as the time varying, such as fading or Doppler, or non-linearity of the system. Convolutional noise, for example, zoom reverberation, which is the convolution of speech and zoom impulse response. Handling such kind of noise can be done by transforming non-additive noise into additive noise using homomorphic processing. The speech enhancement methods can be classified according to their application methods. So, they can be divided into the following two categories: digital signal processing speech enhancement methods and machine learning-based speech enhancement methods. Among them, speech enhancement with digital signal processing is the mainstream method with a long history and has deep technical foundation, which is the main idea of speech noise reduction in the engineering community. In the traditional digital signal processing method, according to the number of channels, it can be further divided into monaural single-channel speech enhancement method and microphone array multi-channel speech enhancement method. That's all for this session. See you next session.